You know, it's hard to draw, but this is a square. So that's a perfect square, okay? And I'm going to lay a perfect circle over top of that perfect square. Imagine put like it's a 4-inch square, I put a 4-inch diameter circle on top of that. How many places along the edge of that square will the circle touch? 4 places, that's right. Yeah. And where will it touch? Yeah. The edges, but where on the edge? Right in the middle, yeah, right in the middle. That's the perfection of math, right? Okay. So if you put a see the last one. Put a circle in there. 1, 2, 3, 4. Pretty simple. Okay. Now that's if you're looking at the circle straight on, right? If I wanted to draw a circle straight on, I could use a compass. Everyone knows what a compass is, right? Okay. I could trace around something, right? I could trace around something. So there's easy ways to create that perfect circle. Unfortunately, we don't look at it straight on. So what happens is that this, remember we did the 8.5 by 11 sheet of paper, right? That 8.5 by 11 sheet of paper, we looked at it at an angle. Everybody wanted to draw it like they knew it. Like that, right? But when we finished our drawings, remember, it ended up looking, you know, maybe something like that, right? Or shortened, right? We didn't pinch these sides in that much, but something like that. So it becomes quote unquote distorted, right? Went through all that. So imagine taking that piece of paper, and you're going to do that today. You're going to create planes that aren't really there. Okay? I want you to create the plane. You'll see why in a second. Imagine taking that piece of paper and looking at it from the side that this circle's on, okay? Imagine there's a circle on that sheet of paper and looking at it from the side. It's a perfect square. Its shape, again, is going to look something like that. And it's not even 8.5 by 11 sheet of paper, right? It's shorter, right? It's a square. So this might even become more distorted, right? But the circle's still inside of that thing. Chris, you okay? I know it's warm in here. I'm so sick of the gray skies.
The seasonal
Have
effect
we
of
had sun at all?
Yeah.
No, you did. Yeah.
Oh, no.
Oh.
Here too.
Oh, did we?
Yeah, it's just behind the
Oh, it's behind the clouds. Okay. All right.
right there somewhere.
Okay. I digress. So how do we put a circle in there that once it's in perspective? Yeah, you find those same 4 points exactly along the edges, right? Exactly. How do I do that? That would make sense. I could literally measure here, right? Literally measure here, right? Except remember, the back half of this plane is smaller than the front half.
I would put an X.
So you go back to the X technique. That's right. Yeah. Like we did in the side of the house, right? It's just a plane that's tilted this direction rather than the side of the house. But you can still find the middle. So then you put your lines through like that, right? Good. So you don't even need to measure. You can just do verticals and horizontals with these diagonals where they all cross. Will give you the visual middle of this, okay? So now I can construct a shape in that plane by creating arcs that is indicative of the circle in perspective. Okay, that's called an ellipse. I can't do it with one fell swoop. You have to do line after line after line after line after line, and then erase away and get a nice looking arc there. If I looked at the circle straight on, Three Stooges reference there. It's curly.
Basically, yeah.
Some symmetry, right? Perfect symmetry there. This equals this equals this equals this in mirror form, right? Okay. So I'm going to ask you about the symmetry of this ellipse. So left, right. This shape, this ellipse, side of the ellipse, if I flipped it over, would it be the same as this side of the ellipse? Left-right mirroring.
It should be.
It should be, that's correct. Yep, it should be. Yep, just the opposite. So it gives you a way to gauge that. This X in the plane and all that sort of stuff gives you a way to gauge that. How about the front half of the ellipse versus the back half of the ellipse, if I split it that way?
No.
Yeah, no.
Well, how could it be foreshortened?
That's right, that's it exactly. So that's another oddity about this. You're drawing a perfect circle that is purely symmetrical, and the left-right relationships of that ellipse, elliptical form, are the same, but the front and back aren't. Okay. Somebody's messing with this. If it's a perfect circle, it should all be the same, right? But it's not. Okay. Everybody understand that? So here's the dilemma. This is what you're going to struggle with today. How do you figure out how much of that imaginary plane that might be, because we're going to have you imagine as a piece of paper. I used to have students do that, so be thankful I'm not doing that. Cut out a square that's the same diameter as this. I don't know if we did that, Javon, when you guys were doing that. And I had the students set that square piece of paper on there and then draw that plane, okay? But I think you can just imagine the plane, okay, rather than draw it, okay? But how would I figure out how much of that imaginary plane I see front to back versus width of it?
It depends on where you stand.
It depends on where your eye level relative
Yeah,
thing. That's
yeah.
right, exactly. So when it's down here, it changes. When it's up here, it changes, right? Okay. So it's going to change depending upon your point of view or perspective, right?
Yeah.
Yeah, that's what we're dealing with, perspective. So everybody grab the cylinder for a second and close one eye and be very formal about this, okay? I mean, you got to. It's like you're sports adventures. Close one eye. If you can grab the like this, that's fine, or maybe you have to use two hands, but try to keep the bottom clear and the top clear. Raise the cylinder until its top is at eye level. At eye level, not above eye level, at eye level. What does the top circle look like now?
Straight line.
Straight line. How can a circle be a straight line? That's a riddle.
It's a rhetorical question. It's not possible.
You're not seeing it at all, right?
Yeah, I can't see it, yeah.
Now take it above eye level. What's happening to that curve?
Getting bigger.
Now the person.
Smaller.
Is it a happy curve or a sad curve?
Oh, it's frowning.
It's a frowning curve.
It's depressed.
Yeah, it does this, right? You don't even see up into it, do you? It's like an arc like that, right? Now keep going up until the bottom is at eye level. What's the bottom look like?
Straight line.
Straight line, yeah. Now go down till you can just barely start to see the circle. I mean, barely. It looks something like this, doesn't it? Yep. Is its width changing in any of those positions? No, it's not. What is changing?
Perspective.
No, what, more specific.
Depth.
What relationship?
Front to back.
Front to back. Yeah, that kind of top to bottom on the paper, right? The front to back. That's correct. Yeah. How would I figure out how much of this I am seeing and actually render it? Visual measurement. Yeah, that's our buddy visual measurement. We've got to always go back to that. That's why that's the first thing we do in this class, right? So you would take your pencil, right? You'll probably use the pencil tip, right? Slide your thumb up, right? So you grab it just, in this case, in this scenario, a tiny little increment, right? Then what do I do with that increment? Wait a minute, what? No, you could. That's in a second. We're going to do that, but we're just looking at this ellipse right now, so we're not thinking about the rest of it.
See how many times I fit inside
The width.
the width?
Yeah, it's a basic kind of height to width relationship. Always think of that. You got two scenarios kind of generally functioning when you're trying to visually assess something, visually measure something. You got height versus width, okay? And always go for the shorter fitting into the bigger, okay? So I would take this, turn the pencil sideways, keep the measurement, right? And then I would stack it across here, right? Find out how many times that stacks across there, okay? That's how you find how much of that ellipse you're seeing. Because otherwise, you're bound by your brain, and your brain is saying that that ellipse might look something like that, right? Because you know it's a circle, right? I've seen that I saw it yesterday. People drawing that ellipse way big like that. So that might, hold on a second, Chris. So that might fit across here twice, and in reality it's fitting across 4 times. Your brain's getting in the way. Go ahead.
Is this girl a radio tower?
Huh?
Yeah.
Don't be so literal.
They're all satellites now. It's actually not accurate.
I did. You're right.
One's right out there, so.
Beep, 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 beep. Sending the signals out to the universe, right?
Yes.
Okay. I didn't mean to, but you are correct, sir. Okay. So, if, let's say the scenario that I'm looking at, oh, sorry about that. The ellipse looks something like that, okay? That's the real thing. So I measure it with my pencil, and I turn that sideways and go, oh, it fits 3 times in real life, okay? On your drawing, what you're going to do is you're not going to draw the ellipse right away. You're going to draw a plane, a 4-sided figure, that represents that measurement, okay? So the first thing you draw, and I'll walk through this with you, this is just kind of an introduction to it, is a line that represents the front edge of that piece, that square piece of paper that's an imaginary square piece of paper setting on top of the ellipse, okay? Everybody with me? This gets real complicated, but it's important because I want you to conceptualize this cylinder in a very kind of diagrammatic way, like a diagram. It's like a diagram of the cylinder. It's not a drawing of the cylinder, it's a diagram of the cylinder based on visual measurement. Okay, so let's say that's the front edge. Front edge of what I'm going to make into a plane. So I'm going to have 2 sides receding, right? That's pretty easy. It's 1-point perspective, so they, like we did that with the piece of paper right in front of us, right? And they don't pinch in much. Yesterday's class took them in, they kind of tilted in too much, so they don't pinch in much. I don't need to worry about that yet, because the next thing I need to worry about is the back edge, right? So how do I find out? There's my thing I was looking at. It was a 3-to-1 relationship. How do I find out where to put that back edge? Like we did with 8.5 by 11 sheet of paper. Remember, I'm just drawing the imaginary plane that is covering that ellipse perfectly.
That's your visual measurement.
Yeah, and what'd I get?
3 to 1.
3-to-1. So what do I do here?
Draw a line.
Huh? A line, or I can put a little mark or something, right? I got to take a guess, right? Or I do a third, right? It's not always that simple, but what Ted's saying, instead of taking a guess here, right, and then measuring that guess and stacking it across 3 times, this is the one. He's saying just break this down into thirds and then apply that, right? Yep. And then you put the line across, and then these barely pinch in, and voila, I've drawn a plane that represents the angle at which I'm looking at the top of that ellipse, right? Or the top of that cylinder. Everybody with me? Right. So how do I draw the ellipse then in that plane?
Make your X.
Yeah, I go back to that technique, right? I put the X there. Boom, 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 boom. And I want you to show all your work. You're going to do 2 drawings. You do one very diagrammatic, and then another freehand, okay? So this one is the one that I want you to show all this work, all this kind of struggle. And then I just start carving the ellipse in, right? Now that's easier said than done, by the way, because I'm going to make a little bigger version of that. So I got my dot here, dot here, dot here, dot here. When you make these arcs, everybody tries to do it in one fell swoop, and then the line kind of looks like that, right? Because it's impossible. You got to go back and forth. You got to use the gesture of your arm and your hand to make the arc. And then you erase away the excess. It's a carving process to make a nice ellipse. And then here, you can turn your paper too. That tends to help, depending upon how you make your art. But here's the problem.
Looks like a lemon.
Yes, it might look like an almond, or a lemon, or a loaf of bread, or depending how you're drawing it. Yeah, but here's a loaf of bread version. People go over too far, and then they get here, and then they go, oh. Look at, they're not hitting they're hitting up here and running the whole length of that line, and then leaving the line down here because they know they're going to get back down here again, right? Okay? So you got to finesse this. If this gets too pointed here, it's a football or an almond, or, So it's a really tricky maneuver to get the right trajectory of this arc, so that when you get over here, you can kind of soften that angle up. Okay? And then as I'm leaving that, and I'm only going to touch it in one place, as I'm leaving it, I got to arc this up and then slowly bring it back down again. So I don't have that. And this takes a lot of work to figure this out.
I have a question.
Yeah. But you got this, by the way, Ted, hold on. What you have here in this scenario is this structure to help you see that, right? You got this X in the plane and everything. Go ahead.
To help finesse that, until we actually learn the physical discipline of it, would it make sense, when you put that first X from point to point on the plane, and then you do your vertical and your horizontal, you wind up with 4 quadrants.
Right.
Could you then do the X technique on each of those quadrants and keep bisecting so that you've got further coordinates through which to draw the curved line?
Well, the thing is that this shape right here,
Yeah.
there's no point at which this thing will hit the edges of any of this shape right here until you get to here and here and you have that already figured out. What it would help you do is it might help you see where this thing is kind of intersecting that line right there.
That's what I mean.
Yeah. You can just look at that, by the way. You could measure that. I could literally measure this right here, take it over to my other side, and apply it right there. And if I have one the same, I know the other will be the same. The negative space, essentially, are measured. Yeah. I've never done that. I'm not sure how that would work, but it might be worth a try to create further structure to the thing, right? Yeah. Yeah, try it. See what happens, yeah. But you at least have that here. I could literally measure this over to here and apply it to here. Couldn't do it up here, right? Because these are different, right? But I could measure this here and apply it over here to make that the same. So you do have that. You do have some information embedded in this first diagram that will help you do that. But try. Yeah, that makes sense. Yeah, might do so. I never did that, but it might really make a difference. So okay, but you do need to use your arm when you're doing this. Okay. All right. Okay. So here's what you're going to do. So it gets tricky. I'm going to do an illustration of what you're going to be working on. So here's your piece of paper. And I want you to break this down. You did this last time, right, Hannah? So I'll have you do it like Javon's doing in class. Once I see a student work through this, then I'll have you do it. Here's your piece of paper. I'm going to run in there in a second and get a. And you can fold it in half. You don't need to. I mean, it's not a big deal, but I want you to kind of envision 2 sides to it. You're going to do a freehand version of the cylinder here. You're going to do a diagrammatic version of the cylinder here. Okay. All right. So I'm going to start the drawing here on this side. Here's the cylinder. Let's say this. I'm drawing a scenario. There's a couple more markers in there. I'm going to run in and get in a second, probably. Right. Break down. Let's make that. So the taller you are, the more of this you'll see, right? The higher up you are on it, right? Okay. This, by the way, on the cylinder, or on the ellipse, or any cylinder, like a bottle, you're drawing a bottle or a cup or you know, a table or a wheel or whatever, this is always right across from this. I always see students do this when they're drawing like a wine glass or something. They'll tip the ellipse. So they think that by making this corner higher than this corner, they're trying to create a sense of perspective, right? Something's going back in space, right? Never, you don't need to do that with the ellipse. It's always that, if it's setting on a flat surface, that's the caveat. Setting on a flat surface, that this corner, what I call them corners, they're not really corners, but this corner is always right across from this on a diagonal, okay? And obviously that's not, or on a horizontal, that's obviously not a horizontal, right? It's tipped a little bit, right? So you've got to be careful about that. Okay, so here's the ellipse I'm looking at, and here I want to draw my diagrammatic version, okay? Whose bright idea was it